And yeah, also Dr. Salvucci from the Faculty of Computer Science. The work is about driver distraction. The whole framework that I focused on was on performance and vulnerability of transportation networks. And in this presentation, I focus on driver distraction. The question is how we can model vulnerability of a network due to driver distraction. The inputs are the physical networks, the traffic demand, and percentage of the distracted drivers in the network, and the type of the distraction. And the outputs are supposed to be the overall traffic conditions over the network. But is this problem important or not? Let's look at this quick movie and see if it is important or not. Distraction is like you don't see because your eye is off the road, right? Times more chances of crash because of distracted driving. $6,000 deaths per year because of distracted related accidents. Okay. So it is important, right? So I grouped the current research into 4 groups. The first group are the naturalistic research. Basically, they have physical real road networks and they do experiment on them. But they are risky and basically dangerous and expensive, right? The other, I would say, the most common way to model distraction are physical simulators, which they invite people for that and they do the physical simulation. Still, it is expensive and time-consuming. The other one are the statistical work, which depend on the how your data, the accuracy of the data. And the last group are the computational models, which we use in this research. One of the examples of the computational models is distract-R, which is developed by Dr. Salvucci in Computer Science Department at Drexel. But basically what it does, it tries to simulate the behavior of a distracted driver on a single lane following the lead vehicle. So it's just a very simple environment, but then what you can do is you can see the change of the behavior of a driver. I want to basically escape this one to go to the other one. On the other hand, there are traffic simulation software, and what they does is basically they look into the detail of the behavior of each driver, and they can model. For example, you can have a large model, right? You can have several drivers driving in the model. You can define all of those behavior for each driver and see what happened in terms of traffic condition. However, these models cannot simulate driver distraction, right? So what we did, we tried to propose an integrated model to integrate the distraction simulation models and the traffic simulation models. In the first phase, we focus on distraction simulation. Using distract-R, I will just show you some results here. Using distract-R, we will see at each single time step, which is 1/10 of a second, whether the driver is distracted or so it means that the driver is driving and then distracted driving, distracted, you see, we can have this time profile for each driver, and for each type of distraction, text messaging, dialing, conversation, we can have these from distract our model. And what we can do is then we can use that as the input of traffic simulation. What we did, we developed an interface using Python code, and we communicate with the traffic simulation software, which is VISSIM traffic simulation software. What we did at each trimester, whenever a vehicle enters the network, based on the percentage of the distracted drivers, first we'll decide if that specific vehicle is distracted or not. If it is, we will assign one of those distract time profile to the driver, and then at each time step, which is 1/10 of a second, we'll check the status of all of the drivers on our network, and we'll see if they are distracted. We use the distracted behavior, which means basically they don't interact with the change of the behavior of the lead vehicle. If not, they use the default basically model. Then one important thing for these computational models is validation. We had 2 validation cases studies. This is one of them. What we did, we tried to replicate one recent study done by Dr. Stavrinos and her colleague in 2013. They had like a physical simulator, different conditions of like roads, free flow, stable flow. So these are what we did. They had the physical network. What we did, we tried to simulate that in VISSIM or in our model, and then we tried to replicate the results and compare the result with their result. And we realized that the model and our results are in line with their results. And finally, I want to just show you one quick result of my thesis, and then I'm done. What we did, this is a real part of the Philadelphia network. This is a real interface of I-75 and I-475. So we modeled that. Now we can do multiple type of driver distraction, which means that in our model, we can have, for example, 2% of the driver are doing texting, 2% of them are dialing, and 2% of them are on a conversation. We can define all these things, which was not the case before. And then this is a very beautiful result that we observed. These two are I would say, the variability in speed and headway distance. It shows that when the number of the distracted drivers increase in the model, the fluctuation in speed and headway distance increase, which basically translates to the basic decreasing the safety of the network. And also the average headway and average speed decrease, which again, it basically impacts the performance of the network negatively. And also we observed that increasing the number of distracted drivers, for example, by 30%, even the undistracted drivers behave badly because of the impacts of the distracted driver. So, to conclude, the contribution is that before, multiple driver distraction was not basically possible to model, and multiple types of distraction simultaneously also was not possible to model, which with our model we could do that. And as the future work, what we focused was on longitudinal behavior and performance of a driver, which means like the change in the speed or headway distance. Later, we can add lateral behavior as well, and also we can focus on producing the accidents in the network, which means that if somebody is like distracted, he or she may generate an accident in the network. We want to see if we can model that to basically model the real world. But that I would like to say. Sorry, I'm not sure how much of it.
Very good. Behind, you'll have to reserve a question.
Sure, we'll sing over the topic break.
Sure. Okay. Thank you. And we still have one.